Hello again. Once again, this is Ben Polzine, former petroleum engineer, now data scientist. And for those who are not familiar, I'm working towards my TensorFlow professional certification. And I now have a playlist of videos here going through some of the projects I've been working on. I have a couple of computer vision projects I highlighted before, and today I'm going to dive into this natural language processing project that I've been working on. Natural language processing, or NLP, is a great avenue of deep learning, artificial intelligence. And when you start to combine it with computer vision and speech recognition, really starts to feel sci-fi, like the movies that inspired us as kids, the way we're interacting with computers and technology these days. And so this project is going to go over the entire NLP workflow, gathering the information, tokenization, cleaning it up, feature engineering, and all the way through to the interpretation of the results and making some predictions on our text. Was brought in all of the necessary packages. Once again, going to utilize the Keras workflow, and then also get into the K-train workflow, but we'll talk about that a little bit later. So let's go ahead and dive in. Going to be working with the IMDB reviews dataset. It's another very popular data set in machine learning research. Contains 50,000 IMDB reviews, 25,000 of them labeled positive or negative for training, and 25,000 of them for the test set to make your predictions with and tune your model on. So really great data set for NLP in a really straightforward problem. So something that we can really dive right in on. So loaded up the data set. Had to do some conversions to get everything into the right arrays, right structure and everything for our modeling. And then utilize the tokenizer functions from the TensorFlow package. But tokenization is a process of reading in the sentences and converting each of the words in the sentence into an associated number. And it uses a process of stemming and lemmatization to essentially boil the word down into the core word. There's a lot of nuance in the English language. There's a lot of variation in the vocabulary. And so it's a pretty complex process of taking the words, boiling them down into their root words, the true meaning of the word, and then giving it a number associated with it to feed into the model to learn on. And some other things going on here with some padding and things to make sure that all of the reviews end up being the same length, using a special token so that a model can handle any reviews in the future, even if there are words that were not specifically trained before. So really, nice thorough tokenization going on, but really good practice building these up. And so what we're going to do is apply this to natural language processing is a little bit more complex than some of the other straightforward deep learning models. There's a lot of nuance in the English language. A lot of words can mean multiple things depending on the context and depending on where in the sentence they appear. So the sequence of words matters a lot, and their context matters a lot. And so we need to build a special model called a long-term, short-term memory model that's able to pass this information throughout the sequence so that it can learn that context and learn the nuance of the language. And so we'll use a long-term, short-term memory, and specifically a gated recurrent unit. I'm going to be using some acronyms, the LSTM and the GRU from here on out, but really just a great model for natural language processing. So once we have our model defined and we build our test harness like we've done before, we can dive in and start modeling using some general default parameters and get going. And we can see we've got an accuracy of 81-ish%. Didn't take too long to run, which is pretty good for a baseline, but these learning curves, again, show clear room for improvement. And when you consider comparing to somebody who's very familiar with movie reviews, they likely perform much better than 81%. So we have some clear room for improvement, but we're off and running. So the next video, I'm actually going to spend a bit more time diving into the approach of how we can really dive in and really improve this model in the knobs we can turn and what we can do. But for now, this is a great introduction to the NLP project, and hopefully you'll enjoy the next one as well.